Hello everyone, welcome once again to my channel. Now this will be the last part of the central limit, and then this question is a combination of both the normal distribution and also the sample distribution. So we are going to look at how to go about this question, and then now from this video, the next set of videos is just going to be on method of movement, maximum likelihood, and then test hypothesis. So that will be the next set of videos. So please like, subscribe, and also hit the notification bell to be notified anytime I post a new video. So let's quickly look at this question over here. Now the question says that the entrance exam scores of a university has a mean of 74 and a standard deviation of 6.8 if the exams follow normal distribution. So in the question we are told that it follows a normal distribution. So if it follows a normal distribution, the first question says that you find if a student is selected at random, what is the probability that his exam is less than 65? So let's write out the possible values that we are given. So we are given the mean, which is the mu, which is the population mean, 74 here, and then we are given the standard deviation here to be 6.8. so it can be this or that. And then if the exam follow normal distribution, then the first question says that a student selected at random, what is the probability that his exam is less than 65? So the probability that the exams is less than 65, and that is what we are looking at in this case. So now if you look at the probability over here, you realize that we are not given the number of samples, right, in this case. So because it is a normal distribution, so it has to follow a normal distribution pattern. So we have z for the normal distribution. Then again, from the formulas we wrote, we said that for the normal distribution for this, we are going to use the normal distribution, and then the normal distribution here is given by, we have our x minus the mu here being divided by the standard deviation. So over here you realize that we have the number of samples basically is equal to 1 here. Basically it's equal to 1. So from here we have x here, which is the 65 here, minus the mu, which is 74 here, divided by the standard deviation 6.8. so basically it's just the square root of 1, but because it's normal distribution, you know, it is this formula. So over here when we compute this, we should get the value to be negative 1.3. so we have this, remember this is supposed to be in the probability, so it's supposed to be in the probability sign. So we have z here less than, with the whole of this we should get negative 1.32 in this case. So that will be negative 1.32. now remember it is less, so we just go straightly to the point, then we get the file of negative 1.32. now using the z table, we have to locate, so there are two things. So this time we are going to use the negative z table. So negative z table, we are looking at negative 1.3 on the right hand side, and then also at the top we look at 0.02, the negative 0.02. so it's negative 1.3 by negative 0.02, and then so from the table you can see from the screen, realize that we have everything to be this to be 0.093418 here, 418 here, which is, you can just leave it in percentages also. So we just multiplied by 100%, which is just 9.34118% here. So in percentage, you can also leave it in percentages. So that will be the probability for the first part. Now let's look at the other part. Now for the other part, for the second part, we are given that, so the second part says that if a sample of 50 students is selected at random, what is the probability that the mean exam of this group is greater than 75? So we are given the number of samples, and then we are given, remember, the mean exams. And then the question is also saying that if a sample, so this is a sample distribution, so we can say that we can find a sample distribution in a normal distribution question. So with this one, we are going to use the sample distribution formula in doing this, in computing this. So let's look at that. We are looking at the probability, so that is the B part, the probability that we have the mean score greater than 75, right? So if that is the case, then we have the probability that Z here is greater than it is the mean over that standard deviation divided by the number of samples. So we have this to be, we are given this to be 75, and then from the general one we have the population mean to be that standard deviation is giving us 6.8, so 6.8 here, and then we have it's divided by 50 here. So it's the same thing here, because over here we could write this whole thing as the square root of standard deviation squared, and then n. Yeah, so it's still the same, so we can put everything in the square root, just that we will have to square this one. And then so doing this, then we are just going to get, remember, it is greater than, again it is greater than, so it becomes 1 minus the file of computing the whole of that, and then we are just going to get here to be 1. So doing that, then we have this to be 1.04 here, right? Now if you look at the Z table, looking for this value, we have this to be 1 minus the whole of that. So on the table we are looking at 1.0 by 0.04, 1.0 on the right hand side, and then 0.04 at the top there. And then when we do that, we are going to get this to be 850,830. So you can also try using a calculator to do that, but then if you use the calculator, let's say you use R in doing this, it's just straightly going to give you the answer. But then when you use P, you are going to get this, and then from there you can now subtract and then get the final answer. So when we do this, we subtract that, we are just going to get 0.14917 here, which is just in percentage 14.1917 just percent. All right, now for the third question, for the third part, we are given this to be, it said what is the distribution for the mean exam score of the student, the mean exam score of the student. So the question is asking for the mean. What is the mean exam score of the student, right? And then we establish that from the sample distribution, the mean is to approximate the normal distribution to be the mu, and then we have comma this over the square root of n. Remember from the formulas that we did for the central limit, we said this formula here, so that's what we are using in solving the mean score here. So we said so we are given 50 students, so the number of students here in this case is 50 students, and then remember our mu is still 74, and then we had the standard deviation is still 6.8. Then we have this to be, we said 50 students, so the number of students is 50, and then we have mu here just equal to 74, and then we have 0.96167, yeah, and that will be the mean score for of 50 students. All right, so thank you very much for joining me in this session. I hope this session was helpful. And then in the next section, we are going to talk about the method of movement, the maximum likelihood, the test hypothesis, and then the rest. All right, so thank you very much, and then I will see you in the next video.